Hello, and welcome to Summarize Science. We all know fake news is a huge problem, and many hope that AI can help us fight it. But to train a smart AI, you first need a really smart dataset, which has been a major challenge. This paper introduces a powerful new dataset called TAGFN, designed specifically to teach modern AI how to detect fake news. So, what makes TAGFN special? As you can see in this diagram, it doesn't just look at a news article in isolation. It creates a social network map, or a graph, for each story. The main point, or root node, is the news itself, and the branches are the users who share or engage with it. This means the AI can analyze the article, the user posts, and the structure of how it spreads, all at once. This is a big leap forward because, as this table comparing different datasets shows, previous resources were often missing these crucial pieces. They either lacked the raw text that modern AIs need or didn't include the social graph structure. TAGFN is also built on a massive scale, using real-world data from sources like PolitiFact, Gossip, and Reddit. With this new dataset, the researchers ran a series of tests to find the best way to spot fake news. They tried simply asking a powerful LLM to judge an article with no examples, a method called zero-shot. Then, they tried giving it just one example of a real and fake story before asking, which is called one-shot learning. Finally, they compared these to a more traditional method of training a specialized graph learning AI, or GNN. One of the most important questions was, what part of the data actually matters most? This chart shows the results of an ablation study, where they tested the AI with different parts of the data removed. The full graph, which includes the news, the user posts, and the network structure, gave the best performance by a significant margin. This proves that the context of how a story spreads is a critical signal for determining if it's fake. Looking at the results, the specially trained graph AI, labeled here as EMV plus GNN, consistently performed the best. But the results for the LLMs were fascinating. Giving the AI just a single example boosted its accuracy dramatically compared to giving it none. Surprisingly, giving it 2 or 3 examples sometimes made performance worse, possibly because the long prompt became too confusing for the AI to handle effectively. So let's recap the key takeaways. The researchers introduced TAGFN, a large, realistic, and publicly available dataset that will be a valuable resource for developing better fake news detectors. Their experiments prove that context is king. The social network structure and user interactions are vital clues for spotting misinformation. This work highlights that while powerful LLMs are a promising tool, we are still figuring out the best ways to use them for complex tasks like this. Ultimately, this dataset paves the way for a new generation of more sophisticated and trustworthy AI to help keep our information landscape clean.